Welcome back, folks. In today's class, I'll start with the chapter number 7. Just wanted to tell you from now onwards, everything will be by using pen and paper, and your final exam will also be by using pen and paper. No Excel from now onwards. And one more thing I wanted to tell you, final is not a comprehensive exam. What does that mean? That whatever we've done before the midterm, that won't be on the final. There is no question from those topics. All right, so let's dive into today's work. In today's class, our focus will be mainly on uniform distribution. But before talking about the uniform distribution, I will tell you that it is a part of continuous probability distribution. So, do you remember from chapter number 6 a little bit what we talked about? We mainly talked about the discrete probability distribution. And in discrete probability distribution, we said that we basically use the whole number. What is the probability of getting one out of a on a dice? So if you throw a dice has number 1, 2, 3, 4, 5, 6. What is the probability of getting one? So you said that 1 over 6. And what is the probability of getting 2? You said 2 over 6, and so forth. Not 2 over 6, sorry, my apologies, 1 over 6 to getting the probability of number 2. Okay, and that's what we discussed in the discrete probability distribution. Means probability of getting 0. 0 is 1 over 6. What is the probability of getting 1? That is 1 over 6, and so forth. Every number had its probability, and we also said that the n value is a whole number. So means number of chances. So for example, in a classroom, how many students can be there? There can be 30 students, 31 students, 15 students, 16 students. There can only be a whole number. Okay, so n will always be a whole number. And now, when we talk about the continuous probability distribution, we will talk about the set of values. So what does that mean? First of all, so between two whole numbers, for example 16 and 17, there can be infinite numbers which can exist between these two numbers. For example, the measurement, I can go to the market. What is the probability that I'm going to buy 16.5 kg of sugar? I can buy 16.5 kg, I can buy 16.525 kg, I can buy 16.53575. There are infinite numbers between the two numbers. So these continuous probability distribution basically is used for measurable quantities. And if this was the probability distribution graph for a discrete probability distribution, for continuous probability distribution, the graph's gonna look something like this. The something like this. So what is the probability of getting 0 to 1, 1 to 2, 2 to 3, 3 to 4, 5, 6? Every section has an equal opportunity. Now we're gonna try and understand the continuous probability distribution uh, in a little bit in detail. So first of all, within continuous probability distribution, there are two types of graph you will be doing. One type of a graph you've already seen in chapter number 3, which is the uniform distribution graph. Sorry, my apologies, which is a normal distribution graph, which you've already seen in chapter number 3. So a normal distribution graph looks something like this, and this is a part of continuous probability distribution. And the second type of a graph, which we will be focusing on in our today's class, that is uniform distribution. Uniform, this is normal distribution. So a uniform distribution graph looks something like this, the one which I've drawn on top, and again I'm drawing it here. Okay, so I'll try and understand the uniform distribution with the help of an example. So let's say you go to the Best Buy and wanted to purchase a TV, and and you wanted to install the TV also. And then the agent tells you that the TV guy will come to your house between 10 to 2 p.m. So you're given a window that he's gonna come between 10 to 2 p.m. So it means uh, every hour has equal opportunity. So if I start from 10 to 2 p.m., this is the window they've given, 2 p.m. Or I can write it as 14 also. So 10 to 14. Now Uh, Now, if I were to ask you, what is the probability that agent's gonna come to your house between 10 to 11? 10 to 11. So that is 1 hour. So there are total 4 hours. I can divide it into four equal segments. So what is the probability he's gonna be in this time? So you're gonna say it will be 1 over 4. So probability of agent coming between uh, 10 to 11 is 1 over 4. What is the probability of agent coming to your house between 10 to 12? So you're going to say, well, 10 to 12, you're going to shade these two sections. So that will be, you can also call it, because you already divided into four segments. So I will call it as 2 on top and out of four segments. So 1 over 2 between 10 to 12 p.m. And each and every hour there is an equal possibility, or shall I say every minute has an equal possibility of agent coming to your house. So that's why this is a uniform distribution, a straight line. All right, now here is a trick question I'm going to ask you. What is the probability that agent's going to come to your house exactly at 12 p.m, exactly 12 p.m? So, I mean, I'm not saying 12.000001 second. I'm not even, he has to be exactly at 12. So the probability of he coming to your house exactly at 12 p.m. is literally zero in this case. So in discrete probability distribution, if I go back and look into this question, what is the probability of getting a zero exact number? So you said 1 over 6. What is, if I put it in this question where we are dealing with the time, what is the probability of agent coming to your house exactly at 12? You cannot find out that probability. So when it is a continuous probability distribution, and uniform distribution is a part of continuous probability distribution, there is no, you cannot define the probability for an exact number. So probability of agent coming to your house exactly at 12 p.m, that is, you cannot define it. Okay, we cannot define it. All right, uh, now let's take one more question on this one. What is the probability that agents gonna come to your house in the last 1 hour? So probability of agent coming to your house between 13 to 14 hour. Okay, so we're gonna put less than equal to now. So agent coming to your house between this time, that will be equal to uh, that will be equal to 1 over 4. That's actually, I will not be putting an equal to sign in this case. Okay, because you don't cannot have the probability for exact 13 or exact 14. So that is 1 over 4. Now, there are certain formulas which I will encourage you guys to look into your formula booklet. These are the formulas. So this is the formula for uniform probability distribution. So how this formula works? So if this is the uniform distribution, I will place A, B on the bottom side, and C, D the section on which we are looking the value for. So this is C, D. So this is how it's gonna look like. Probability of C less than C, X greater than C less than D is equal to D minus C, means this section, D minus C upon whole of the section, that is B minus A. That's how we're going to define the uniform probability distribution. Now, to find the mean value, this is the formula we're going to use. Mean value is equal to a plus b upon 2. So a plus b. So in the previous case, if I have to find what is the probability he's going to come, what is the mean value, expected value, this mean value is also called as expected value. Expected value. So what is the when you are expecting him to come to your house? Okay, so you're gonna say 10 to oops, 10 to 10 to 2 p.m., or I can call it as 14. So this will be equal to I will put 14 plus 10, 14 plus 10 divided by 2, and that will be equal to 24 divided by 2, which is 12. So he's expected to come at round about 12 p.m. So this is also called expected value. Now we can find the variance by using this formula, and we take the square root of that value. That's going to give us the standard deviation. So these questions on variance and standard deviation, I will encourage you guys to solve it by yourself because they are relatively easy to find out. And yeah, I'm going to take one question on the uniform distribution from the book now. So this is the question, and let's look into this question. I'll highly encourage you guys to pause the video and first of all read the question, because if you understand the question, only then you will be able to solve it. Now, let's look into this question. A hotel offers the breakfast to its guests between 6:30 a.m. to 10 a.m. The manager of the hotel wishes to connect with the specific guest about a concern they had during the previous day and is hoping to catch them when they come for the breakfast. However, the manager does not arrive until 7:30 a.m. Assuming the manager knows nothing about the specific guest prefer time to eat the breakfast, but knows that the guest tends to come fairly steadily throughout the entire breakfast time. What is the expected value of the distribution of the time that guests come down for the breakfast? Expected value, EX. That will be equal to bigger value plus smaller value divided by 2. So it is a uniform distribution question. So 6:30 a.m. 6:30 a.m. to 10 a.m. Now, here is a tricky part about a question when you are solving for the time. Here it is written as 6:30 a.m. 6:30 a.m. I just cannot put it as 10 minus 6:30. We cannot subtract the math value with the time, so, or add also. So we have to put it, this will be wrong. So 10 plus 6.5 means 6.5 divided by 2. This will be the correct way of writing it, and that's going to give you 8.25. Once you're going to do the math, please make sure if you're going to put this value in the calculator, you put a bracket around it so that you get the right answer. 25 means quarter of an hour, so 8:15. 8:15 is the expected value. All right, so hopefully you were able to understand how to solve a question when specifically the time is given to you. What is the probability that the manager will be on the duty when the specific guest wishes to come down for the breakfast? All right, the manager does not come until 7:30 a.m. given to us. So he does not come until 7:30, does not come until this time. This is the time he is there. So we will write down it's like this. So probability of he being there, that is between 7.5, because 7:30 is 7.5, x less than 10, between this time. So we will write it as 10 minus 7.5 divided by 10 minus total is, this is 6.5, this was 7.5, and this is 10. So this 10 minus 6.5, that will give us 0.714. So hopefully you were able to understand this question. Mainly whenever you are solving a question on the on a uniform probability distribution, you will be given that it is a question on a uniform probability distribution, or the question will include the time. So these will be your two hints to solve the question. It will be mainly a time question. Okay, so that's it for today's class, and I'll see you with another video. Till then,